Welcome back, everybody. This slide will cover the rest of your book. We're starting on Learning Task 3, page 24. Rick talked about flanges. They're used to make connections that can be easily taken apart. Page 24, 25. Here we have screwed and weld neck flanges. Screwed flanges are used on small, low-temperature piping systems, and depending on its service, they can be welded on the back of the flange for a leak-proof joint. Weld neck flanges are commonly used on high pressure and high temperature systems. The flange is butt welded according to job specs. A slip-on flange is welded from the back and the front. They are cheap and easy to install because they only require fillet welds. Socket weld flanges create leak-proof joints on small diameter piping systems. It is very important to always gap socket joints or they could crack under pressure. We will cover this in the shop when we get back in there. Here you can see symbols used for flanges. This is good stuff to know so you can identify them on a blueprint. The blind flange will close off the end of a piping run and are extensively used for safing out vessel work. A spectacle blind, sometimes called a figure 8, is helpful for doing maintenance on big piping systems. You can flip it for blinding and deblinding really easy. The blinds must be engineered and they must have stamps on them when you're using these things. The stamp will indicate size, type, and pressure rating. The higher the pressure, usually the thicker the blind. Generally a 150 pressure rating is 1/4 inch thick and 300 is 3/8, and the higher the pressure rating, the thicker the flange. When you're blinding and deblinding, always know what you're working with, and if it's a gas plant, always use fresh air to protect yourself. Reducing flanges will reduce size of a piping run. They can be slip-on or screwed. They can be eccentric or concentric. Remember about the eccentric, it reduces the pocket of stagnant liquid when the pipe is run in a horizontal plane. In your book, page 27, figure 10 shows raised, ring type, flat, internal and external tongue and groove flange faces. Flange specifications. When you're looking at these, you will see the nominal pipe size, pressure rating, flange face type, type of flange, how it's connected, and the wall thickness. Pressure ratings are given in pounds per square inch. Standard ratings are 150, 300, 400, 600, 900, 1500, and 2500 psi ratings. Out of this whole section, the only test information is the weld neck flange symbol on page 25. Moving along, if you're following in your book, we're on page 31. We're going to look at piping drawings. Some of this is review from foundations. Site plans are viewed directly above the structure as if you were in a helicopter. Plan, elevation, and sections use orthographic projections. A reminder that orthographic projections, they view the face directly towards you. So they'll have a front side, a right side, a left side, top and bottom side if you need them. Unlike the isometric, which are drawn at a 30-degree axis. Single line projections show individual pipe runs are more common for fabrication. Spools and drawing views. Spool drawings give you detailed information for the welder and the fitter. In the picture you can see 3 different drawing views. Note that on orthographic the dot indicates that you are facing the open end of the fitting. Nothing from this section is on the test, but we will practice going over spool drawings in the shop. It's pretty important to know how to pick these things apart. Moving along, next section in your book, a little bit of pipe layout. Here we have pipe bending. A bend allowance is a calculation of how much material you need to take into account for bending a piece of material. The decimal number you see on the screen, 0.01745, is a constant value that we will look at in the next slide. Bending pipe will reduce time in welding and reduces time for inspectors to come by and do quality control. Page 4 in your book, here's an example of a 75-degree bend in a 400mm pipe. In the formula, R is the radius of the bend and D is the number of degrees of the bend. When calculated, the length will equal 400mm times 75, which is our degrees, times the constant value of 0.01745, and the result is 523.5 millimeters. On page 5 and 6, there are examples of using parallel line development to make a template for pipe. Sometimes these are called wraparounds. Templates are generally made from thicker cardboard-like paper. This method can be used for making elbows, T-joints, square and rectangular transitions. Parallel line development is done by dividing the pipe into a certain amount of equal sections, and then you lay this equal sections out on a flat surface. Laying something on a flat surface is known as a stretch out. To find the stretch out, you must know the outside diameter of the pipe. From there, you multiply pi to get the circumference. And then from here, you can segment the pipe so that you can create elements on your stretch out. Here's an example of segmenting and stretching out for a miter development from start to finish. Miters can be used to develop 45 and 90-degree elbows. In our course, we are going to make a 3-piece 90-degree elbow using parallel line development. So you guys will get lots of practice with this. In your book, page 10, figure 12, angle of cut and fit. For all there's need to know is the angle of fit. For a branch and a header, you need to know wall thickness. Usually with this, you have to reduce one wall thickness so you don't have a very sharp corner that will reduce time in grinding later on. Here are some basic pipe layout tools. The centering head and torpedo level, they're used to mark center lines on pipe and for checking angles. The contour marker is helpful for laying out miters directly on the pipe. It saves a lot of time messing around. Here's the last summary for the book. The test for this book is 21 questions. Remember about the symbols. It's very helpful to draw them out because they will be drawn out as a symbol on your test.